Hi everyone, we did our final project on average reaction times. This is Team 32. I'm Peyton Boniface.
I'm Ben Cranston.
And I'm Zach Skidmore.
Starting on our background information, there have been a lot of studies trying to decide whether or not age, gender, or identity of a person has any correlation with their reaction time, specifically male versus female or older versus younger. Um, and one impact of this possible difference between men and women is becoming increasingly relevant in our culture is esports. Esports right now has been dominated by males, and so and with the rise of competitive video game and popularity, reaction time can determine who wins titles, tournaments, or even millions of dollars in prize money. So analyzing which sex is faster, or if there is even a difference between male and female at reacting to changes in a screen could decide the future of esports. So our question is there a significant difference between the reaction times of current male and female students? And of course, our inference population then are the current pool of male and female students. Onto the data collection. The random variable for our test is the average reaction time of our subject. The data we collected was during the afternoon of November the 13th. And one factor that we couldn't control was the exterior lighting due to the change in time of the day since we took these samples over several hours. And sometimes the sun would peek through the clouds and provide an extra glare on the screen, so that would make it harder for someone to react in time. How we collected the data was that we asked students walking down Main Street near the TUC if they were able to complete a quick survey to determine their reaction time for a study. And how the app worked is it started on a red screen and the screen would turn green and the student would have to tap the screen as fast as they could to the color change. And then that time was recorded in milliseconds. And they did that 5 times to collect an average time, which was then recorded and put into a Minitab. And of course, in between the trials, the phone was cleaned off with disinfectant, and I held the phone the same for every single test to alleviate that variability. In total, we collected 31 female and 37 male data points for our experiment, and now I'm going to pass it over to Ben for the analysis of our data.
Thanks. Thanks, Peyton. So the analysis of our data, first off, because we had under 40 samples, we need to do an Anderson-Darling normality test and prove the data is normal. Then a 2-sample t-test was performed on the data, and analysis of that sample shows there's a significant difference, and the p-value is approximately 0. We'll go more into detail on this in subsequent slides. So this is the probability plots showing like an Anderson-Darling normality test performed by Minitab. You can see the p-value of both samples is greater than 0.05, which indicates that the data is actually normally distributed. So this allows us to move forward with calculations using a 2-sample t-test. Here's like our 7 steps. The parameter of interest here is the mean difference between the two populations. Mu1 is male and mu2 is female, just to keep that in mind. So our null hypothesis was that the two populations are the same. The difference is 0. The alternate hypothesis is that the male population average minus the female population average is greater than 0. In other words, the male population average is greater than the female population average. Or is lesser than, I apologize. Sorry about that. The test statistic is shown there. And we reject the null hypothesis if p is less than 0.05 because this is a 95% confidence interval. Calculations were performed using Minitab once again, and we'll go on ahead, but the p-value was less than 0.05, so we reject the null hypothesis. There's enough evidence to reject the hypothesis. The mean reaction times of the populations are the same. If you look at the Minitab results, what's really important here is the test in the bottom right corner. We see the t-value is negative 6.52, which is very close to 0% of the data if you really look at it. And the p-value is very close to 0, which of course indicates that we reject the null hypothesis. So we can look at these box plots and they kind of show the average distributions of the data and such. And obviously, this isn't necessarily the best representation, but this helps to kind of visualize the data a little bit and where it falls. So I'll pass this on to Zach now. Thank you.
So in the end, we ended up rejecting the null hypothesis. This means that the average reaction time of the male and female UC students are probably different. This is based on the data that we gathered. In order to truly prove the alternative hypothesis, more data would need to be gathered. This study that we did was then compared to a similar study done at a university, and they found similar results where males had a faster reaction time than females. In our midterm, we found that male UC students on average have a slower reaction time than the average person, according to the Human Benchmark website. The study that we did could be expanded by collecting data from more students here at UC or going to more universities around the country or even going global and comparing the two samples populations then. In addition, a more comprehensive testing method could be derived by controlling the lighting. As mentioned, being outside caused potential glare and made it hard to see the color change. And also screens have their own delay that could be mitigated or changed. Overall, because of the consistency of the data and the confirmation of similar studies, confidence can be had in the conclusions about this data. Then to round things off, there is a citation for the comparison of male students at UC to the Human Benchmark, and then the study that we compared our 2-sample t-test study to.